We're going to look at question D on page 2, and we're just continuing with our focus on the ideal gas law. So what I've done is in the space above question D, I've brought over two really important things for you to use to complete the question. I've brought over the ideal gas law formula, PV equals nRT. You can see that in blue. And I've gone through each variable and listed out its only possible unit in red. So remember, P stands for pressure, that must be in ATM. V stands for volume, that must be in liters. N represents mole, moles is its own unit. I'm going to skip R for a second. T must be plugged in, converted to Kelvin. So you're going to always take your Celsius and convert it to Kelvin. If the question gave you the temperature in Kelvin, then of course you don't need to do any conversions. R is a constant, which remember that means it's always that particular value. So the version of R that we're using is 0.08206. It has the units liters times ATM over Kelvin times mole. So that's your ideal gas law formula. Remember, that's the formula that you will be given. It's exactly as a formula that's written on your formula sheet. It's on the front cover of this packet, and you're also given R. I've also written for you in green and highlighted it in yellow your conversion for Celsius to Kelvin. So remember, you just take your Celsius, you add 273, and that's your temperature now in Kelvin. Because any gas law formula must have its temperature in Kelvin. You can't use any other unit. So question D says, what mass of helium gas, so I know I'm going to be looking for mass. What mass of helium gas, and there's just a reminder there for you that helium is on the periodic table. It's the symbol uppercase H, lowercase e. So what mass of gas is needed to pressurize a 100 point liter, that is my volume, a 100 point liter tank to 255 ATM. 255 ATM is my pressure at 25 degrees Celsius. So 25 degrees Celsius is my temperature. So let me walk through that one more time. What mass of helium gas is needed to pressurize a 100 point liter tank to 255 ATM at 25 degrees Celsius? So what you're ultimately searching for is your answer for mass. Remember, mass is oftentimes going to be asked for in a unit of grams. If you notice in this question, they didn't specify a unit. So they didn't say they wanted grams, they wanted kilograms. The reason is your unit is always going to be whatever is left over from the formula, whatever unit didn't cancel. I'm going to go ahead and give you a heads up that for this one, it's going to end up being in grams. You should feel comfortable enough knowing that generally speaking, what we've done for our class is if you see the word mass, that's going to end up being units of grams. So just remind yourself of that if that's something that you have forgotten. Okay, let's notice too that this time around, they also gave us 4.003 grams per mole. And so if you were to go back and double check on your periodic table, the atomic mass for helium on the periodic table is 4.03 grams. So the molar mass then is 4.03 grams per every mole. And remember that mole is represented as a 1 mole. The 1 is always invisible. So what we need to do right now is just take a moment and figure out how are we actually going to solve this question? Because you're not solving for pressure, you're not solving for volume, you're not solving for temperature, you're not even solving for moles directly. What you're going to want to do is you're going to want to take your formula, PV equals nRT. We have a pressure to plug in, we have a volume to plug in, We have a temperature to plug in, and of course we always have R to plug in. What we'll be left with is N, which is moles. This time around, you're going to go the opposite route of what you've consistently done this semester. We've usually started with grams and converted it to moles. For this question, you're actually going to have to take your moles, multiply it by molar mass, which they gave you in the problem, and then that's going to give you grams. So just as a reminder, whenever you start with grams, you can always multiply by molar mass to get moles. You could also do the exact opposite. If you started with moles, you can always multiply the molar mass to get grams. If you remember when we first did our introduction to stoichiometry, I would often write this for you on the board, right? G means grams, M means moles. Okay, so now that we have an idea of where we're starting and where we're going, I'm going to go ahead and remove everything that I just wrote out. So if you need to pause the video, please go ahead and do that. And I'm just going to start working through the problem. So the first thing we want to do is we want to isolate for our variable. We have PV equals nRT. We want to solve for n. So that means I want to get n by itself. I'm going to divide by RT on both sides. So now that I've done that, it removes it and I'm left with my formula, which is n equals PV over RT. Okay, let's double check our units from the variables given to us in the problem. Our volume was given to us in liters, so we're all good there. That's the unit of volume that we need for any ideal gas law formula. Our pressure was given to us in ATM. That works because our pressure for ideal gas law must be in ATM. Our temperature was given to us in Celsius, so we're going to have to convert that to turn it to Kelvin, and we're solving for moles. And of course, R is just a constant, so there's no issue there. Okay, let's take the first step. My pressure from the question is 255 ATM. I don't have any conversions to do, so I'm just going to move on to my next variable. Volume was 100 point liters. Remember that 100 point? Those are two trailing zeros with a decimal. So let me go ahead and remind you that that's 3 sig figs. I don't have anything else in my numerator, so I'm going to go ahead and set up my denominator. My denominator starts with R, so I'm going to put in the entire thing, 0.08206. My units are liters times ATM over Kelvin times mole. My temperature, I need to convert from Celsius to Kelvin. So I'm going to say 25 degrees Celsius plus 273. All of that needs to go in my denominator. For this particular question, what I would do is I would clear out my denominator first. So I would add 25 plus 273 and clear that out in the calculator. Then I would multiply that to my R value, which is 0.08206. So once you add 25 to 273 and you get that number, then you're going to separately multiply that to your R value. That's now going to be your denominator. So if you did that part correctly, then your calculator is going to stare back at you with this value, 24.45388. Now let's go to the numerator. You're just multiplying 255 times 100. That's going to be 25,500. So 25,500. So that's your numerator, that's your denominator. Remember, this time around, this is just our first step. We just have to solve for moles before we then convert it to grams. So that now means that my moles would equal, if I were to continue that right over here at the end, I would get a pretty long decimal. So take a moment and divide this in your calculator, and you should then get 1042.779305. And remember, that's your mole for helium. Now you're finally ready to move on to the next step. And if you notice, I'm done now with my formula. I'm not continuing this in one long equation. What I'm going to do now for the second part is I'm going to now take my moles of helium and I'm going to multiply it by molar mass to get my grams. So I'm starting a brand new string equation here. This is no longer part of the formula. And so you always want to carry over a calculation answer. You never want to do any sig figs until you're completely done with every single last step. So I'm going to start again with my long messy decimal. Remember, this is moles of helium. And now what I need to do is I need to multiply it by my molar mass. So this is where this value that they gave me in the question, that's where this comes in. Remember, this is 4.03 grams per mole. That's going to help me cancel out moles and be left with grams, which is what I want because they're asking for mass. I want my units to cancel. So remember, if it's 4.03 grams per mole, that's always worth 1 mole. The 1 is always invisible. So I'm going to say 1 mole of helium in my denominator so that my moles will cancel. And I'm going to put 4.003 grams of helium in my numerator. Now, if I track my units, I have moles of helium canceled and I have grams of helium left over. So now I just need my calculation answer. So this now in your calculator, you're going to put in your entire 1042.779305, and you're going to just multiply that by 4.003. Your calculator then should stare back at you with this really long number. $4174.24555 9. Okay, let's go back and check our sig figs. I already went through this one. We said it's 3 sig figs. 100 point, those are 2 trailing zeros with the decimal. Everybody counts. 255, that's also 3 sig figs. If you remember back when we talked about temperature, we said never look at temperature for sig figs. Ignore it. So I just have 3 sig figs, 3 sig figs. That means that I'm going to take this calculation answer and I'm going to turn it into a 3 sig fig answer, and then don't forget the unit. So that's the only problem I'm going to have you work on for today. Just make sure that you've gone through, you've shown me all of your work just like I've shown you in this video, and please box or circle your final answer, and you're just going to submit question D for your practice today.